So let's continue thinking about area. Let's find the area between the x-axis and f of x equals 9 minus x squared from x equals 0 to x equals 5. Now in this problem, this is a little bit more complicated because this function actually crosses the x-axis. So if I go ahead and graph 9 minus x squared, it's a parabola that's concave down, you'll notice that that parabola crosses over the x-axis at 3. So if I want to find the area between the x-axis and the curve, I'm going to have a piece above the x-axis that I see right here, and I'm also going to have a piece below the x-axis, which I see down here. So what I need to do to find these areas is I need to break this up into two separate pieces, one from 0 to 3, and the other one from 3 to 5. So I'm going to need to find the definite integral from 0 to 3 of 9 minus x squared dx, and that's going to come out to be a positive number. I'm also going to need to find the area from 3 to 5 of 9 minus x squared dx, but that's going to come out to be a negative number because that area is below the x-axis. Since what I want to do is find the total amount of area, I don't want these areas to cancel out, so I'm going to take the absolute value of whatever I get there to make that a positive number. And so what I'm going to end up doing is I'll go from 0 to 3, and then I'll go from 3 to 5 with these two definite integrals. So let's work them out. So let's start with the definite integral from 0 to 3 of 9 minus x squared. So what I need to do here is I need to find the antiderivative and then evaluate it from 0 to 3. So the antiderivative of 9 minus x squared is 9x minus x cubed over 3. And now I need to evaluate that at 3 and 0. So I'm going to plug those numbers in and then subtract. So when I plug in 3, I get 9 times 3 minus 3 cubed over 3. When I put in 0, I get 9 times 0 minus 0 cubed over 3. And notice that whole second part in parentheses there is just 0. So if I simplify the first set of parentheses, that gives me 18. So that first area that we looked at before is simply equal to 18. Now I need to do the same thing down here, but the difference is going to be I'm going to take the absolute value of my final answer to end up with a positive answer. I'm going to go ahead and I'm going to take my antiderivative, 9x minus x cubed over 3, and I'm going to plug 5 and 3 into it and then subtract. So I'm going to get 9 times 5 minus 5 cubed over 3 minus the quantity 9 times 3 minus 3 cubed over 3. And when I work that out, I get 44 thirds. So the piece of area that I had above the x-axis from 0 to 3 had an area of 18, and the piece of area that I had from 3 to 5 below the x-axis, it comes out to negative 44 thirds, but in absolute value, that's positive 44 thirds. So the total area is going to be 18 plus 44 thirds, or 98 thirds. Notice when I did this, I had to break this up into smaller pieces because I didn't want a positive and a negative area to lead to some kind of cancellation of areas. So in summary, to find the areas bounded by f of x, x equals a, x equals b, and the x-axis, we have to use the following steps. The first thing you're going to want to do is sketch a graph over that interval. Find any x-intercepts of f of x in a to b, and then divide the region into subregions. The definite integral will be positive for subregions above the x-axis and negative for regions below the x-axis. So we'll use separate integrals to find the positive areas of those subregions, and we might need to take the absolute value to do that. Lastly, the total area is the sum of the areas of all of the subregions. Make sure all the subregions are made positive before you add. That way you don't get any cancellation. And so that's what we did in our previous step when we broke it up from 0 to 3 and 3 to 5, because 3 was an x-intercept.